Let's look at graphing nonlinear inequalities. If we've got x minus y less than or equal to 1 and y squared less than or equal to 2x plus 6, what region in the plane does that look like? Well, let's take these and turn them into equalities to look at the boundaries. That's going to be y equals x minus 1. If you move that over and move that over, they both change sign. And that is just a very simple graph. It's got y-intercept minus 1, x-intercept 1, and I'm going to dot that in because the whole thing might not actually be useful as the boundary of whatever the region is. Now this one's a little more interesting when you turn it into an equality. You don't really want to solve that for y. You want to think of it, what kind of curve that is. Oh, it's a sideways parabola. Okay, well let's see, and it's got a shift to it. It's y squared equals 2 times the quantity x plus 3. Okay, so that's in the form y squared equals 4px, but shifted, and it's an x minus h. The shift is minus 3, but there's no shift in y. So that tells us where the vertex is, over here at x equals minus 3, and y equals 0. And it's the p is positive. Let's see, here p is 1/2. We're not going to worry too much about the directrix and the focus and all that because we're not really interested in the classical geometry of this thing, just what its shape is. But it is crucial that there's no flip, there's no negative here, so it's going to open up to the right. So it's going to go like this, and we'd like to know exactly, roughly what it's like. Well, it's definitely going to be, could be interesting to plot the intersections with the axes, and that's going to be easy, so we'll do that in a minute. But what's more interesting is where it intersects with the other curve, because then it looks like we're going to get some sort of bounded region in between, and we'd like to know the corners. So looking at this as a system is going to be crucial in a minute. So in fact, even though it's nice to know what kind of curve this is, I'm not going to try and sketch it from scratch until I actually know those other points. While I'm at it, though, I might as well get, let me put my labels on here, I might as well get the intercepts. That's going to be where x is equal to 0, and that's going to be, let's see if I can squeeze it in somewhere, y squared equals 6. Okay, y is plus or minus root 6. Not a particularly nice number, but not horrible either. Somewhere around 2.5. Okay, so looks like it's going to intersect here. I know my scale's not very good, and here. And I could go ahead and start sketching that, but it's going to be worthwhile to wait until I have the intersection of the parabola with the straight line. Okay, so let me see if I can just not erase too much here. And we just have to look at the system. Well, we've done that. Okay, let's see. Let's solve for x here, y plus 1. That's good because then when we put it into here, we don't have to square anything. So y squared is 2 times the quantity y plus 1 plus 6. Okay, so y squared minus 2y, and then this is 2 plus 6 is 8, so minus 8 equals 0, putting everything on one side. And I've got this out of a book, so it's likely it'll factor. This is the stage where you might have to use something like the quadratic formula, for example. Okay, it's going to factor as y minus 4, y plus 2. You can check that if you want. And so y equals 4, and y equals minus 2. Now remember, you don't just stop there. You need to figure out what's the x value. Well, if y equals 4, we've got x in terms of y right there. Then x equals 5. Okay, so 2, 3, 4, 5. Okay, so it's going to be up here, basically, at 5, 4. So that's going to be one of the points, 5, 4. And then y equals minus 2. I know it's getting cluttered. Y equals minus 2. X is going to be minus 1. So it's going to be minus 2, minus 1. And that's right here. Looks reasonable. Okay, so it's going to go through here. Remember, I got that intercept. And it's going to go here. We got that intercept. And so here's the part of the straight line we actually need. Let me just dot this. And then here's the region in between. Oh, remember, to get the region in between, we need to really remember what were the inequalities. If I erased them, unfortunately, but they turn out to be y greater than here. And here it's y less than or equal to. And we can just do our usual thing. A y greater than f of x, that's always on the upside. Or we could just test the origin. If you put in 0, 0, is it true that 0 is greater than minus 1? Yes. So the origin is on the correct side of this one. And then we could test the origin for this one. Is it true that 0 is less than or equal to 0 plus 6? Yes, it is. So the origin is in there on both, and so it really is everything to the right of the parabola and everything above the line, and so it's everything in between here. If not, it could have been some funky region that went off to infinity, which is not illegal at all, but it's probably more likely that people are going to be more interested in this because it's bounded. In fact, I got this out of a calculus book where the next task is to actually find the area of that, but that's not what we're going to do in this problem.